Welcome back, everyone. We're just going to do a bit of work on substitution and evaluation. And I see this as a little bit of a game. We're looking, I want you to scan the question and I want you to see what the value of the letter is going to be. Okay? And then we substitute that in. And it's kind of similar to what you're doing in primary school. Every time you got a worksheet and there was a box and you put the number in the box and then you crunched the numbers and you got a numerical answer. We call this substituting and evaluating. So when you see those words substitute and evaluate, you know you're going to get a numerical answer. And I'm going to show you a few little tips to help you do that neatly. I think one of the big problems is that if you don't set it up nice and neatly, I know that's really hard, but neatness is your friend here, and if you do it like I'm going to show you, then your eye will naturally double check that you've got everything in the right place and you'll make fewer mistakes. Okay, it's not perfect because you can still make the mistakes of crunching the numbers and all that kind of thing, but if we set it up well, we give ourselves the best chance of getting it correct. Okay. Welcome back, everyone. We're just doing another little video on algebra, and to this lesson we want to look at the word substitution and evaluate. What we need to keep our eyes open for, and I'll draw my little symbol for an eye here, is when we're in the game of substitution, we're told that n equals some value, a equals something. Okay, so we look at the algebra, we see the pronumeral, the letter, and we substitute in the number. And then we evaluate. Evaluate, I just think about it as crunching the numbers, and we're going to get a number as the answer. And a lot of students will feel comfortable with that because they like seeing their answer just as a number. So here's the opportunity to practice that. And I've got a really simple one. What I want to just show you, if we see something like this where we've got 2n plus 1 and we're told the value of n is, let's make it 3. Okay, I often write this down. I write the algebraic expression, comma, and the value all on one line together. Now my next step, I'm going to drop down here, put an equal sign, and you can put a times and then the value of the letter, then add 1. So what do we got? We've got 2 times 3 is 6 plus 1 is equal to 7. Another way to do it, and I'll just do this line again, you'll often find me use a set of brackets. Okay, wherever I see the letter, I replace it with a set of brackets and put the number that I'm substituting inside the brackets. Now, to me, that's implied multiplication. We talked about that in the previous video, that without writing it, there's a times sign in here. Without writing it down on this line down here, this is the same thing as 2 times 3. I read it as 2 times 3. 2 times 3 is 6 plus 1 is equal to 7. So our maths is the same. So I just got a couple of other examples. This won't be a long video because I'm just kind of setting up the questions that you'll see in the textbook. I might put a line there and change the color of my pen and start thinking about some other questions. All right, so I've got an expression. Well, I've got two expressions. what I want to work on. So they're kind of similar. 4p minus q plus 2. Okay, and I'm told that the value of p is equal to 3 and the value of q is equal to 10. It says that in the question. So I can do my substitution step, and I'm going to use my brackets, and in this case I can put my 10 in plus 2. So now we're up to the evaluate stage. We've done the substitution, we're evaluating this, we're going to get a number as the answer. I might take another line here just to show you. This is 4 times 3 is 12. Subtract the 10. I didn't really need the brackets. I hesitated for a bit there, and finally add 2. So what do we got? We've got, that's the same thing as 12 plus 2 is 14. Take the 10, so we're at 4. Positive 4 is my final answer, and I've just got a number as the answer. So let's practice that again. I have got p times q, even though we write it without the time sign. And in here, I'm going to add 3 lots of, in brackets, q minus 2p, close the bracket. Okay, so substitution is really important here. Here's our numbers over here. I've got to be really careful now. 3 times 10 plus 3 lots of 10 minus 2 times p, which was 3. Double check, make sure that you get the substitution step correct. And I like to line the letters up, and I like to work underneath, like I'm demonstrating to you here, because with my eye I can check that the letters and the numbers that I've substituted in are directly underneath one another, and that's my little check that I don't make any mistakes, well, too many mistakes. So 3 times 10 is 30 plus 3 lots of, I'm going to do the work inside the brackets here. 2 times 3 is 6, 10 minus 3 is 10 minus 6, sorry, is 4. And that is the same thing as 3 times 4 is 12. I'm just going to put a line through that and write 12 plus 30 plus 12, we're at 42. Okay, so just be really careful there. I've got one more example I want to work with you here. We're using we're using p, and the value of p this time is 4, and the value of t is 5. We're going to use these pronumerals and the values here in the orange. Okay, so let's set this up. 3 times p squared. Now the value of p is 4, so we can write this as 4 substituted in. Keep everything the same. All I've done is change the letter to the number that it's corresponding to. So p equals 4 here. I've used that. Now I've got to be really careful. This is a squared up here. So I've got to do 4 times 4, which is 16. So my next line kind of looks like this, 3 times 16. And then I can think about maybe doubling 16 to 32 and adding 16 to 48. Okay, my final answer is just a number. So let's try the next one. We've got something here like t squared plus p to the power of 3. Got to be careful with our indexes here. I'll do the substitution step. T is 5 squared plus p to the power of 3. So that's 4 to the power of 3. So now the crunchy, grindy stuff. 5 times 5 is 25 plus 4 to the power of 3. I need to think about that as 4 times 4 times 4. Okay, 4 times 4 is 16, times 4 is 64. Add those together, and what are we left with? We're left with 89 as our final answer after we've done the substitution. Okay, one more question, because I just want to point this out to you. I know there's a couple of questions there that involve the square root sign. So we've got p to the power of 2 plus 3 to the power of 2. Now there's a couple of ways we could answer this question. We're going to do the substitution, and we've got 4 squared plus 3 squared, and underneath here, just a reminder of what to do. Underneath here, 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. So what we have here is the square root of 25, and that's equal to 5. Okay. Having done the substitution step, you could have done this slightly differently if we come back and set this up. If this is 4 squared plus 3 squared, you might have seen that using squares. You might have seen this as 4 by 4 plus another row on the end and one in the corner would be how I'd use the other 9, and that's 25, 5 squared, or 25 little blocks there. And if we take the square root of that, which is just the one-dimensional length of that, and that would have been equal to 5 as well. So there's all these different ways to think about and work, but I just want to reinforce with you now that the substitution step is really important. And the best way to do it is, I think at least, is to set things out, write out your algebraic expression or equation or whatever you're dealing with, drop down underneath on the next line and do the substitution, and then crunch the numbers, do the evaluating next. Treat them as different things, and take a couple of lines to set it up and work it out. The biggest trap here is that I see mistakes from students who just try to do too much in their head. All right? And even if you are a really good student and you find this stuff easy, there'll come a point, if you don't practice these steps, there'll come a point where it'll become hard because you just cannot see the answer and you haven't practiced the technique.